Okay, so today's lecture we will finish the convolution, so this calculation of convolution. Basically it will be examples in how to do the convolution in either the graphical way or the equation way. So today is Friday. The reading is from page 4058. That was for today's lecture. While in Monday lecture will be review for the test. So it will be review for exam 1. So I wanted to, I'm not going to give a new topic, so there's a chance to review the exam. So most likely it will be, I already posted in Canvas a sample exam. So it will be just the answer of the sample exam in Canvas. You can see on Canvas files the sample exam and their answer. So I will go only through the answers of this. And most likely, or actually there will be no live meeting, so it will be posted online. I think I might post it even today or tomorrow, so we'll see. So it will be posted online on panel to report. Which is basically, I think it will be half an hour related to the answers of the sample exam. So I will go through the answers in details. It's not mandatory. You already have the file or the exam and the answers as a PDF file. So if you want to watch it, you can watch it at your convenience. So again, no live meetings, so you don't need to show up. You can study, take this time and study for the test. The test will not be hard, it will be something simple, so the difficulty level will be similar to the sample exam as a difficulty level, not as a questions. The questions, of course, there will be different, even different idea. But here, just like the sample test, is just to tell you and a clue how is the difficulty level. So in Wednesday, February 14th, it will be the exam. So exam 1 will be between 10 a.m. until 10:15, which is in this classroom. Try to come 5 minutes or 10 minutes early, so I think I might start 9:55. But officially starts at 8, so it will end, either way, it will end at 10:50, so if we start earlier than 10, it will still end at 10:50. And I think that this might take 35, 40 minutes at times. That's how I plan to make the test. And you are allowed to have a note sheet 3 by 5. Make sure to write your name and write your ID, which is either email or banner number. And keep in mind that it's double-sided. You can write whatever you want, no problem with this. But don't share this. So if you write any information, this is yours. Don't share it with others during the exam. I mean, before the exam you can share it, but I did mine. But I mean, during the exam, don't share it with anyone. Okay, then make sure to submit this with the exam. So you need to write your name. Okay, so on Friday, the 16th, we will start a new topic. Most likely we will go through frequency domain. So we are done with time domain, we will go to frequency domain. So the overall idea, just in general, why we need to go to the frequency domain, we see here in convolution, there are a lot of integration, a lot of math. So this makes it more complicated in doing the convolution, especially with more complicated signals. So you need to do some complicated integrals. Therefore, we will move from time domain to a frequency domain. Frequency domain will make the life easier, especially in convolution. It will convert the convolution to something called multiplication. We will talk about this later, but actually we will go to the frequency domain to make the life easier. It looks like, I think, if you already know the differential equation, right? So there is one way of solving the differential equation by using Laplace transformation. Is this correct? And in Laplace, the derivative will be as times S operator, the integration will over S operator, something like that. So the same thing that we will do it in signals and systems, but we will do it more in the application. So we realize that if we use Laplace transformation or later something is called Fourier transformation, this will make the convolution easier, so we will not use this kind of complicated integral. Therefore, we will realize that what we are doing in real life, we are not actually using convolution, we will be using the frequency wave. Okay. Any question about the exam? So again, the exam will be material until the end of today's lecture, which is on convolution. And I will not have office hours on Monday, but if you need to see me, I can be available in Tuesday. So Tuesday, I think between 10 to 12. I'm not sure, but in case if you need to see me, send me an email so I can give you the right time or the right place. Okay? If you cannot make it in person, we can do it in Zoom as well. Okay, so last lecture, we started this example. So we said this is x of t, this is h of t. We already written this example last lecture, so you don't need to rewrite it again. So you can just continue with what we did. So we did the convolution when t less than 0 or 0 between t and 1, t larger than 0, then we end up having this. And we said y of t can be also represented as this form as 0, t of t, or u of t. Or in other words, I can represent y of t as t, u of t times u of t minus u of t minus 1. This represents actually 0t, that's what I did. Then plus u of t times u of t minus 1. And this represents for t larger than 1. We should know how we did this because we already did this a lot when we explained the function u of t. So that's how we make the interval. Then we don't need to make it write it as this way, we write it as this way. Either way, both. If you write it in this way, that's correct. If you write it in this way, that's correct. So what we did last lecture, we used the graphical method. Now there is another method for this example. Method 2, which is using the equations or using the math formula. Using the equations or the math formula. How? We know that given that x of t equal u of t and h of t equal u of t minus u of t minus 1. That's what we have given in the question, which is that given in the question. Was given in the question was to be like this, and the h of t was given in the question like this. Okay? Now, we need to do it in math formula, which is we know y of t equal x of t convolved with h of t. Now substitute the values. X of t we have, which is u of t, convolved with u of t minus u of t minus 1. Okay? Then, if you need, well, let's distribute this because it's distributive. U of t convolved with u of t minus u of t convolved with u of t minus 1. So when we make it to u of t, this means integral. Then here, integral with phase shifts. Integral with shifts. And as we know, r of t equal u of t convolved with u of t, right? Or the integral of u of t equal r of t. Whatever you prefer, both of them are the same. So this yields to, here's just a note, yields to be u of t convolved with u of t will be r of t and subtract u of t, r of t, but there is a shift, so it will be r of t minus 1. That's it. This is y of t. This is the same as what we know before. Then, if you need to represent this as a graph, it will be like this. Here is 0, here is 1, here is 1. So this is the other method, or the other way. By doing, instead of making these shifts, we can do it in math using the problems. So we can use whatever more convenient, or it depends on. Sometimes I to say use the graphical method, sometimes use the equation method. If you see no information about this, then you can use whatever you use. If there is nothing written in the question, use the graphical method or use the equation method. Use the easiest method for you, or whatever you want. Then you can do it. Okay, any question? Quick notes. Whenever we have a causal system convolved with causal, this will give us a causal output. Causal means input causes output. Most likely means you will not see anything in the t less than 0, so most likely it will be something like this. All of them larger than 0. This yields to causal outputs. So as a result, in causal system, causal, it will be y of t, which is x of t, convolved with h of t. It will be the same thing that we used to know, which is between 0 to t, x of tau, h of t minus tau, d tau, but we will add something to it, which is times u of t. This will be outside of the integral. That's the difference when we have causal, which is basically, we will multiply this by u of t. Okay? Let's go to an example. Example 2, which is where we need to use the graphical tool to solve this. So we have assumed that we have x of t like this. So here is 0, 2, 1. This is x of t. Then we have h of t given like this. Then h of t is given like this. Okay? Then let's do the convolution. So we have method number 1, which is a graphical. So in order to do this graphically, let's convert x of t to be x of tau, h of t to be h of tau. So here we will have, here is tau, here is h of tau. The same thing, but here for h. So this is going to be tau. Let's do first h of negative tau. So h of negative tau means a mirror on the axis here. So here is 0, negative 1, here is 1. After that, I need to make it as h of t minus tau. Here is tau. Then it can be like, we can make it like, for example, here is t minus 1. Okay? So this is h of t minus tau. Then this block is moving because dependent on t. Okay? That's what we will have. So our target is, when we do the convolution, y of t equal to the integral from 0 to t, x of tau, h of t minus tau, d tau times u of t, because all of them are cosine. So this is clear. Okay. Now, how we can do this? Let's do dividing in steps, because depending on the value of t, if there is any change in t, if it is negative, positive, it can be between negative infinity to infinity. So let's do different values. Let's assume case 1, when t less than 0. When t less than 0, I'm going to plot x of t and h of t together. So we have x of t fixed, x of t position fixed, or x of tau actually fixed, between 0 to, this is x of tau. Now h of t, if we assume is negative value, then t is negative. So here t minus 1, here is t. Okay? Because t is negative. Do you agree with me here? On this graph? Because t is negative. Now, is there any overlap? No area, no overlap. No overlap. So the area is 0. Therefore, y of t equals 0. Okay? Is this clear? Case 2. That was case 1, now case 2. Case 2, when t larger than 0. Okay, let's try to plot the function and see. X of t is fixed between 0 to t, x of tau. Then t, now it's positive, so t can be here. I can assume t between 0 to 2, so because here I need to have between this period, so let me assume it between 0, let's see, do we need to wait to 0 to 2 or 0 to 1? Basically, let's see, there will be overlaps. That's my plan. That's what's happening. So there will be something called partial overlap. But the width here that we have between t and t minus 1. So we have some cross-section area, and we have partial overlap. Width of x, width is h of t minus tau. This is x of tau. So width of h is 1. Width of x is 2. So which one is lower? H. So we will stop between 0 t to 1. To 1 because h is lower, between 0 to 1. So what will happen is basically we will look here, there's something we call it again partial overlap. Partial overlap. So y of t will be the integral between 0 to t, and keep in mind t now here is less than 1, x of tau, h of t minus tau, d tau times u of tau, u of t. So x of t during this period is equal to 1, integral of 1. H of t minus tau, look at the red color, which is 1 as well. So both of them, h is 1 and x is 1. D tau, the integral between 0 to t, u of t. This is the integral of 1 is t tau, and tau between 0 to t, this will yield to make it t u of t. Okay? So now case 2, we are done. Basically, we did try to make it overlap between 0. We stopped at 1 because the lowest width is 1, that's why we stopped at 1. Then let's go to case 3, when t larger than 1. So case 3, when t larger than 1, so let's plot what's happening. So we have x of t is fixed with width 2, while here is x of tau. H of tau, it is when t larger than 1. So here, 1 minus t minus 1, and we have t less than 1. We have here t. So the width of x equal to width of h is 1. So we already talked about 1. Now the other thing, which is 2, we will put it here. The other width is 2. So it will be between 1 to 2. So during this, when it's between 1 to 2, t between 1 and 2, this yields to be all of them fully completed, fully overlapped. Fully overlapped. Then we have here t less than 2, and we need to make sure t minus 1 a lot larger than 0, t leads to t larger than 1, so as a result t between 1 to 2. So here we have completed overlap. How to find u of y of t? Y of t is the integral between 0 to t, x of tau, h of t minus tau, d tau times u of t. This yields to be the integral of 1 here between t minus 1 to t, then 1 times 1 d tau times u of t. And during this period, since t larger than 0, u of t equal 1, so this yields to be equal to 1 between t minus 1. This is t minus t minus t minus 1. Therefore, the answer will be 1. Okay? So the point here, u of t will be 1 because we are guaranteed everything it will be 1. There's no need to multiply by u of t. The second thing, the integral terms between t minus 1 to t. Why not between 0 to t? Because look at the area here between t minus 1 to t, not between 0. We are no longer doing the integral from 0. Okay? So the integral terms related to u. Okay? That's case 3. Case 4. When t larger than 2, so let's observe until what shall we start. Let me draw the function x of tau every time is fixed. There is 0, t, 2, here is 1. Then h, here is that one was x of tau, while h of t, now t is larger than 2, which is here, larger than 2. Then t minus 1 can remain here. So yields to partially overlap. So the integral terms will be the area starts between t minus 1, ends until 2. So it will be between t minus 1 until 2. Okay? Because depending on the area. So until what time will it stop? It will remain until t minus 1 leaving that area. When t minus 1 will leaving that area, when t minus 1, it will be within the area when it is less than 2, so t less than 3. So at t equal 3, or let me write it as equal. So it will leave the area, at t minus 1 equal 2. This means t equal 3. Therefore, we will make the integral or the period, the terms between 2. So let's do the integration. And we know here the integration terms between 2 to t minus 1. Again, why? Look at where is the cross section or the overlap. The overlap here happens between t minus 1 and 2. So let's do the integration. Y of t equals to the integral between t minus 1 until 2, x of tau, h of t minus tau, d tau times u of t. We know u of t here says we is positive equal to 1. Then x of tau equal to 1, h of tau equal to 1 in this area. So it will be the integral of t negative 1 to 2, 1 times 1, d tau times 1. So the integral of 1 will be as tau between t minus 1 to 2. This yields to be 2 minus t minus 1, so the answer will be 3 minus 2. Okay? Now, the second thing done, which is basically, or this is actually the fourth step done. The next one, look at the orange or the red shape or the red box or h of t minus tau. It is moving. It starts entering until leaving. Recall last lecture when I showed you the demonstration on Canvas modules. How is the blocks is moving, right? Do you remember this? When it's moving and then we'll see some overlaps, the box entering and leaving. So now we are trying to emulate this step by step. Then the case number 5, when t larger than 3, what will happen? Let's look at this one. So we have x is here, x of tau, then we will have t minus 1, here's t, h of t minus tau, here's tau, here is 0 and 2. So we are guaranteed that when it is larger than 3, if it is larger than 3, t minus 1 will be, since it's larger than 3, will be t minus 1 larger than 2. So there is no overlap, right? No overlap. So as a result, what will happen? We will say that y of t will be 0. That's correct? No overlap, no area, then it will be 0. So we have 5 cases. So the next thing, don't stop here, write the function and plot it. So write the overall function. So the overall, let's group them together. It will be 0 when t less than 0, t when t between 0 to 1. We are trying to group all of the 5 cases to write them in one function. 0 to 1, then it will be 1 when t between 1 and 2, then it will be 3 minus t when between 2, t 3, then it will be back 0 when t larger than 3. So how can we plot this as a graph? This is important. basically, when it is less than 0, here is 0, here is 1, 2, 3, these are the critical points. Then when it is 0, it is 0, then it will keep going until 1, equal 1, it will be increasing. Then here, with t equal 1, keep going, constants, because it will be 1, remain 1. Then at t equal 2, it will start decaying until reaching 3, which will be 0, then back to 0. This is y of t. Okay? Yes?
When you do case 4, how come the intervals not between 2 and 3, but instead between, I guess, 1 and 2 in this case?
Okay, let's go to case 1. The integral between t minus 1 until 2.
Yeah, but this is for partial, correct?
Yes.
So, I guess t starts getting out at 2, is that's why that's the top bound?
Yes, because most likely I'm looking at the integral, where is the area? So the area located between t minus 1 and 2. I cannot do the integral until 3 because there is no overlap. So there must be overlap, only there must be area or the...
So the top bound is when t is at the last part where it overlaps?
So yeah, when I do the terms, t minus 1 until 2, which is the end of it. Okay. Now here I'm done. I can write y of t in terms u of t instead of making it like this way. Basically, it will be t times u of t minus u of t minus 1. This is equivalent to 0 t 1 plus 1 times u of t minus 1 minus u of t minus 2. This is equivalent to 1 to 2. Then plus 3 minus t times u of t minus 2 minus u of t minus 3. Again, this is equivalent to 2t3. That's it. Why the zeros will not be represented? Because 0 times something will be 0. So you can also write also denote this function like this way. Okay? That's method number 1. Method number 2, using the equations and the properties that we know. So let me go do the same question but with method number 2. Using the equations and properties. So given x of t like this, that was given in the question 0, 2, and 1. And it was given also h of t. H of t was given as between 0 to 1. So we need to write the function for everyone. So x of t, x of t is actually u of t minus u of t minus 2. That's the equation. H of t is actually u of t minus u of t minus 1. Therefore, in order to write it, to calculate the convolution, which is y of t equal to x of t convolved with h t, then x of t is u of t minus u of t minus 2 convolved with u of t minus u of t minus 1. Now, how can we do the convolution? Similar to multiplication. You will do this with this one and this one. Then we will do this with this one and this one. Okay? Same thing that we just do in multiplication. So this will be u of t convolved with u of t minus u of t convolved with u of t minus 1, then minus u of t minus 2 convolved with u of t minus u of t minus 2 convolved with u of t minus 1. Okay? Now, we know whenever there is u of t, there is integration. So u of t convolved with u of t, this means r of t. So the first term will be r of t. The second term, r of t with first shift, with shift 1, so r of t minus 1. Third term with shift 2, r of t minus 2. And the last term, fourth term, minus 2 minus 1 will be negative 3, so r of t minus 3. Okay? And if you want to plug it, there will be here is 0, then here is 1, here is 2, here is 3. There will be the same flux that we have. Yes?
Wouldn't the last term be positive because the negative times negative would be positive?
Yes, it will be positive. Yes.
Okay.
Thank you. It will be positive. Plus negative times negative will be positive. That's correct. Then you will realize that this and this the same. If I look at the function u of t, if I look at the function r of t, they are the same. You can convert u of t to r of t. We don't have to do this from previous lectures. So sometimes if you use different methods, it might not be the last final format the same way as what you have, but if you do simplification, there will be it's the same answer. Okay? Any question? Also, I would like to write some properties, or some just as the last property, that just for you to think about. Property or active properties. Let me say property here. When we do the convolution like y of t is x of t convolved with h of t. So we will say the width of y of t equals to the width of x of t plus width of h of t. Second property, area of y of t equals to the area of x of t multiplied by area of h of t. Here is just for your knowledge, for your understanding. How? Let's go back to the example. To the last example, and just let's plot each one and make sure are those satisfied or not. So in that example, we had x of t like this. 0, 2, 1, right? That was x of t. While h of t was like 0, 1, 1. This is h of t. However, what's the other thing, which is y of t? It was here 0, 1, 2, 3. That was the function. Let's try to apply these properties. So look at what's the width What's the width here? 2, right? What's the width here? 1. So what's the width of y? 3. So width of x plus width y of h equals the width of y, which is 1 or 2 plus 1 equal to 3. That's correct. The other thing, which is look at the area. Look at the area. What's the area here? 2 times 1 2. What's the area here? 1 times 1, 1. Okay, what's the area here? We can divide it into like this triangle. So I will say this is area 1, area 2, area 3. Area 1, 1 times 1, 1 times 1 half, 1 half, right? The triangular area. 1 half times base times the height, right? So 1 half. The area 2, 1 times 1, 1. Because 2 minus 1 is 1. Times 1, the highest 1, 1. Then the area of 3, 3 minus 2 is 1. And the height is 1, so base is 1, height is 1, times 1 half, 1 half. So the overall area will be 2, right? So we will say that area x times area h should equal to area y. So area of x equal to 2 times area of 1 equal to 1, 2 times 1 equal to 2. That's correct. Okay? Any questions? Let's go to a third example. I'm gonna go quick. And most likely also I'm gonna upload a few examples so you can, with their answers, you can try them at home. I'm gonna write now the last example in today's lecture. Example. Here is x15. 0 to 2, x2, this is h of t. Now we have h of t. 0, 3, 1. This is h of t. So let's do as h of t minus tau. How will this look like? It will look like, here is t, here is t minus 3. Then we will see how is the overlap between them. So let's do case number 1. When t less than 0, when t less than 0, look at them. Here is x of t. 0 to t, while here is this is x of t, x of tau, and this is h of t minus tau, no overlap, so area equals 0, this is y of t. Okay? Case 2. When t larger than 0, but where shall we stop? Let's try to see. Here is 0, here is 2. So here is 2. T larger than 0, which is in this area. Here is t. So there will be partial overlap. And here is t minus 3. So let's look at t minus 3. T minus 3, it is less than 0, so t less or less than 3. And look at the other thing, which is we have width of x equal to, so which one is lower? Is the width. So we will make it center. Where's the width? So this is h of t, this is h of t minus tau, and we have some overlap. So this will be partial overlap. Therefore, to calculate the integral, y of t equals the integral between 0 to t, because here's the area between 0 to t, thus the integral terms. Then x of tau h of t minus tau d tau u of t. Now x of t is, look at x of t here, which is this area, and this is a function t minus tau, which is linear function, just going down with slope equal 1. So it will be as the integral between 0 to t of 2 minus tau, h of tau equal to 1, d tau u of t. After doing the integration, the answer will be 2t minus 1/2 t squared, all of it times u of t. We kept u of t because t is less than 0, that's why u of t is not 1. That's u of t. Or actually, no, t here is larger than 1, so u of t equals 1. Whatever, let's go to case 3. Case 3. This is h of tau between 0 to 2, while h of t now larger than 2, then t minus 3, since t larger than 2, t minus 3 will be less than 0, so will be less than 0. So we will have this kind of overlap. We need to calculate this area. Look at the integral terms. The integral terms will be 0 and 2. Here is the integral terms. So y of t equals the integral between 0 or to 2, x of tau, h of t minus tau, d tau times u of t. So which will make an integral from 0 to 2, x of t, which is linear because it's moving from 2 and it's going down. So it will be 2 minus tau, h of t minus tau, which is equal to 1, d tau u of t. Then we do the integration between 0 to 4. This yields to be the final answer as 4 minus 1/2 2 squared times u of t. So the final answer will be 2 u of t. That's case 3. Case 4. When t larger than 3, and where we will stop, let's plot to see where we need to stop. So here is 2, this is 0, this is 2. So what's happening here? H of t, h is now larger than 3, or t larger than 3, while 3, t minus 3, it will remain here. So here's t minus 3. And you will see that some partial overlap going on here. So this is h of t minus tau, while this is x of t, x of tau. So in order to look at the integration terms, t minus 3 and 2. Here's the area. Then let's do the calculated integral. It will be, or where shall we stop? We will stop until t minus 3 will be equal to, here we will stop. So t minus equal to, this is t equal 5. Therefore, we will write 5 here. T less than or equal, larger than or equal 3, less than 5. Then let's do the integration. So the integration y of t, the integral between t minus 3 equal to 2, x of tau, h of t minus tau, d tau times u of t, u. Then t minus 3 to 2. This makes the integral between t minus 3 to 2, x of t minus tau, 2 minus tau, we've already counted, h of t minus tau equals to 1, d tau u of t. Then do this integration, yields to be 4 minus 2 t minus 3 minus 1/2 4 minus t minus 3 whole squared. Then after making more simplification, it will be 1/2 t squared minus 3t plus 12.5. That's the other thing. Then the last thing is 5. When t larger than 5, here in this situation there will be no overlap because let me make x of t first. Here is x of tau. While we have h of t minus tau, t minus 3 minus t. So no overlap. Area equals 0. Yields to y of t equals 0. Then we are not done yet. The last step is to draw the function. Let's write the function y of t equals to 0 when t is than 0 minus 1/2 t squared plus 2t when between 0 t 2, then 2 between 2 t 3, then 1/2 t squared minus 3t plus 12.5 between 3 t 5, then 0 when t larger than 5. That's the whole function. Well, I'm not sure, let's see this two go what's the other. One of the answers here. 2, and 4 times 2 yeah, that's correct. Or you can write it as the last thing. Or you can write it as y of t equals to negative 1/2 t squared plus 2t times u of t minus u of t minus 2. This is for the period of 0 t 2. Then plus 2 times u of t minus 2 minus u of t minus 3. Then plus 1/2 t squared minus 3t plus 12.5 times u of t minus 3 minus u of t minus 5. So this is between the period 2 t 3 and this is between 3 t 5. Then that's it properly. But you can try it at home to solve it using the math formula. So see you on